Did you know that the Sun is so large that over 1 million Earths could fit inside it? It's true. This extraordinary celestial object is not just big, it's the very heart of our solar system, holding everything together with its immense gravity. The Sun's gravitational pull is what keeps all the planets, including our Earth, orbiting around it in a delicate dance that has been going on for billions of years. Without the Sun's gravity, these planets would simply drift off into the vastness of space. But the Sun does more than just hold the solar system together. It bathes us in light and warmth, making life on Earth possible. It's the driving force behind our weather patterns, ocean currents, and even the changing seasons. The Sun is essential to life as we know it. But what exactly is the Sun? It's not a solid planet like Earth, nor is it a gas giant like Jupiter. The Sun is a star, a giant ball of plasma, which is a superheated state of matter. Imagine a gas so hot that its atoms begin to lose some of their electrons, creating a swirling mix of charged particles. That's plasma, and it makes up the entirety of the Sun. The Sun is composed mostly of hydrogen and helium, the two lightest elements in the universe. These elements are constantly fusing together in the Sun's core, releasing tremendous amounts of energy in the process. This energy then radiates outward, eventually reaching us here on Earth as sunlight. The Sun's surface, called the photosphere, is a bubbling, churning sea of plasma that reaches temperatures of about 10,000 degrees Fahrenheit. Deep inside the Sun's core, something truly remarkable is happening: nuclear fusion. This process is the engine that powers the Sun and allows it to shine so brightly. In the core, where the temperature and pressure are unimaginable, hydrogen atoms are forced together with such force that they fuse to form helium atoms. This fusion process releases a tremendous amount of energy in the form of light and heat. Think of it like billions of tiny hydrogen bombs exploding every second. This energy then slowly makes its way from the core to the surface of the Sun, taking hundreds of thousands of years to complete its journey. Once it reaches the surface, the energy is radiated out into space, and a tiny fraction of it eventually reaches Earth. Section 4. Life-giving energy from afar. The energy that reaches Earth from the Sun is essential for all life. Plants use sunlight to photosynthesize, converting light energy into chemical energy in the form of sugars. Animals, in turn, eat plants or other animals that have eaten plants, obtaining the energy they need to survive. The Sun's energy drives the Earth's climate and weather patterns, creating the conditions necessary for life to flourish. It warms our planet, evaporates water from oceans and lakes, and drives the winds that distribute heat and moisture around the globe. Without the Sun's energy, Earth would be a frozen, lifeless wasteland. The Sun is a true life-giver, sustaining all life on our planet. Section 5. The Sun in human history. Throughout human history, the Sun has been a source of wonder, awe, and even worship. Ancient civilizations recognized the Sun's importance for life and often incorporated it into their mythologies and religious beliefs. The Egyptians, for example, worshipped the sun god Ra, who was believed to sail across the sky each day in a celestial boat. The Greeks had Helios, the god of the sun, who drove his chariot across the heavens. The sun played a vital role in ancient agriculture, with farmers carefully tracking the sun's movements to determine the best times to plant and harvest their crops. The sun's cycles also influenced the development of calendars and time-keeping systems in many cultures. Even today, the sun continues to captivate our imaginations and inspire scientific inquiry. Section 6. The Sun's Fateful Journey. The Sun may seem eternal, but like all stars, it has a limited lifespan. It is currently about 4.6 billion years old and is considered to be in its main sequence phase, where it will continue to fuse hydrogen into helium for billions of years to come. However, in about 5 billion years, the Sun will begin to run out of hydrogen fuel in its core. As this happens, the Sun will start to expand and cool, eventually becoming a red giant star. During this phase, it will engulf the orbits of Mercury and Venus and possibly even Earth itself. Eventually, the Sun will shed its outer layers, leaving behind a small, dense core called a white dwarf. This white dwarf will slowly cool and fade over trillions of years, marking the end of our Sun's life cycle. But don't worry, we have plenty of time to appreciate the Sun's warmth and light before then. And who knows what technological advancements humans might make in the billions of years to come? Perhaps we'll find a way to journey to other star systems and witness the wonders of the cosmos firsthand. For now, let's be grateful for the incredible star that sustains us and marvel at its power and beauty. If you enjoyed this journey into the heart of our solar system, don't forget to like, share and subscribe for more awe-inspiring adventures.